Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How you guys and girls doing? Oh my god, I hope you watched the last video because it's really important where I explained kind of what a shader is and how that works. Like, it's a little program in the GPU, just to recap, and it's run for either each vertex, if it's a vertex shader, or each pixel within that object or fragment in that object. If it's the fragment shader, right? There's another shader called a geometry shader, but we'll check that out later. It's used to maybe add more points to or more vertices to your object, like midstream in the GPU. So you can do that if you want. We'll go through all that later and show you how that works in code. But what we're gonna do today is just to simply load shaders. We made two shaders here. I pre-made them, and I'll explain a little bit what this does. Now, remember that in the pipeline, the vertex shader has to get in data, and it's gonna get in all our points that we have. This is for next tutorial, but I still wrote them up here so we can see. These are gonna be our positions, colors, and texture coordinates. Don't worry too much about texture coordinates yet. Just think about each of these points in space, the vertices, having a position and a color. We're gonna get a position in, a color in, and a texture coordinate. We're gonna send it out from the vertex shader to the fragment shader, which it will pick it up later. See how the names have to be the same? And this is what it's gonna do. So we'll get to that in a bit. Don't worry too much about that. I'll just put it aside. What we need to do is to load and create this shader program. So the way this works is OpenGL. In OpenGL, you create different vertex shaders, geometry shaders, fragment shaders. You link them together into one program, and before you draw something, you kind of activate a program. So once it's activated in the background, it's going to be used when you're drawing all your points. So all the points are going to be sent through the pipeline, and the program that's activated, we're going to have all this code here, and this is what's going to happen to our points, basically, depending on what shaders you have activated. So that's how it works. You bind a shader, you bind a model or object with all its points, and you send it in, and you draw it. And you can use different shaders on the same object to get different results and all that stuff. So you're pretty free to play around with that. But to load the shader, it's pretty straightforward. First, we're going to create a shader. All it is a code. It's an ID. So we'll just call it core program. Now I call it core program because it's kind of just the default kind of program. You can make a bunch of different programs. Sorry about that, I just moved my mic. You can make a bunch of different programs and you'll be fine. Load shaders core program. So we're gonna create a program, basically just an ID for it, place to store the ID, and we're gonna load shaders and kind of set this ID in here. See how I made load shaders a Boolean function with a reference to a GLUint program. So we're actually gonna be changing this program ID here. What you're gonna need in order to make a shader, first of all, is all the error checking stuff. We'll get that out of the way. So you want to make a char info log with the size 512, because this is where we're gonna get the info log if a program isn't able to link or a shader isn't able to compile and all that stuff. We'll have a GLInt for the success variable, which we'll get back from the checking of the error if it succeeded or not. You'll see how that works. The way we load shaders is that first we have to read these files. Alright, I created two GLSL files. You can just go ahead and create a new file. Let me show you how I did it. Just any of these files. All you do is just the name has to be whatever.glsl if you want it to be. But just do that. You can select any of these. It doesn't really matter as long as you just rename them GLSL. So that's what I did. So I have these. Now we're gonna load them in using ifstream, and I added fstream, string, and vector to the libs.h. I added this too. You don't have to care about this right now. We'll get to that in the next tutorial. It's basically a definition of a vertex, but we'll talk about that later. If we get back to this, so it's just basically just gonna read this line by line, just like any text file, and it's gonna put it into a string, which we can compile later. Now OpenGL and your graphics card, all that has a compiler for GLSL. So you'll be able to put the code in and it will compile it for you, kind of runtime, so or compile time or whatever. So it should be good. So let's just do this, or rather runtime, I think it is. But yeah, to do that, what we need to do is we need to make a std string temp variable. All right, it's gonna get each line, and then we're gonna have the actual source src. We just call it src. It's the source, all right. And then we're gonna make a if stream. Whoops, std if stream in file. All right, and we're just not going to initialize that yet in the constructor. So what we're going to do is we're going to load the vertex shader first, and to do that we need to do this in file.open. We're going to open, what's it called, vertex underscore core.glsl. So vertex core.glsl. Just make sure this name is the same as this name. Now I'm sorry I didn't really zoom in. I'm sorry, I'll do that now. All right. There we go. So all I've done yet is just do the load shaders. This is all I've done, and I've added, in case you didn't see it earlier, I added this here as well. And here we'll check out this code later anyway, so it's cool. Sorry about that, not zooming in, but it's zoomed in now. So we open the file, right? So we want to check if in file.is open. So if it did open, then we're going to do something. So then we want to make a while loop because we want to get each line in this file. Std get line, use the in file stream that we created. This is how you read from files in C++. Now, if you haven't learned this, basically just go and check out the C++ tutorials I made or anyone else has made to learn, because it's kind of a prerequisite. But anyway, we'll read that in to temp, our temp variable, each line. Now, while it's reading it until we get to the end of the file, we're gonna add it to src. So plus equals temp plus a new line character, just in order to do a new line on each of these. All right, so once we've read that source in, we'll remember to close the file, and here we're just gonna print out a error. std error load shaders could not open vertex file. This is just a basic error, no big deal. Well, it is a big deal if it does come to this, but still, we don't need to throw or anything like that. So that's cool, and we'll close the file. Then another important thing to do is to do temp equals boom and src equals boom, because we'll reuse these for the other thingy later on for the fragment shader. So I'm just gonna do this. I'm gonna make a little fragment, and I'm gonna do program. So remember, we're gonna load the vertex shader in, create it, load a fragment shader and create it, and then create the program and link it. So this is how we create the actual vertex shader. GLUint vertex shader equals GL create shader. All right, and now we want to give it the type GL vertex shader. Now you can see that everything in OpenGL starts with the GL prefixes, right? So and GLUint as well. So just remember that. That's how OpenGL usually works. You give it a function and a type and stuff like that. Now what's happening here is this is the vertex shader ID. It's just like a handle to it. This creates a vertex shader in the background, all right, in its own memory, in OpenGL's own memory, and it gives us an ID so we can keep track of this vertex shader and do stuff to it and use it. So basically that's what's happening. Now we want to, once you do this, OpenGL kind of, okay, now this is the active shader. Right now we created the shader. Now we want to set a source for the shader. We want to give it the source that we read in, and you can only do that in a special kind of way, right? It takes a const gl char array, and this, we'll call this vert src equals our src that we read in from the file dot c string, so the c type string. All right, so now we have it in the format that we want it. Now gl shader source actually lets us set the source to this newly created shader. We'll give it the ID that we got, vertex shader, because we need to give it the source before we compile it. We'll give it one kind of source thingy. We'll give it the actual string, the converted string, mind you. vert src, and just say null in the length. Don't care about that too much. And there we go. We set the shader source. Now we want to compile it. GL compile shader. I want to compile our vertex shader. Alright, so once we compile this shader, all this code is going to be compiled. Now errors can occur. This is something you should and probably have to do according to me, but it's something you can live without, obviously, because it's error checking, and who can't live without error checking? So, but you should do this. All right, you should really do this. And to error check a compilation, what you do is you do GL get shader IV. All right, and you kind of check what happened to this vertex shader. And what do we want to check? Well, we want to check the compile status. All right, to check the compile status, and we want to get if it's a success or not. So we made this success variable, and we'll just say success. So it'll return a -1 or a 1 in order, or depending on what happened. So if success -1 meaning failure, if it's not true meaning -1, anything less than 0, then we have an error. So I'm just going to copy this error string here, and I'm going to say error load shaders could not compile vertex shader. All right, and we do get an info log. All right, so to get the info log, what we do is GL get shader info log to see actually what happened. Vertex shader, this is what we're doing right now. 512 is the buffer size because that is our info log size. We have the length at null, don't worry about that, and the actual info log where we want to put stuff in. So we'll get the info log here to what happened to the shader, and then we want to print that info log out so we can see what happened. std cout info log new line. That's gonna give us the info log of this whole thingy. All right, perfect. Now we want to delete shader, vertex shader, for a reason I'll explain very soon. Once you create the program, you don't need these individual shaders anymore. They'll be linked in this program itself, so you don't need them anymore here, and they're local as well. You want to free up that memory, so remember that. So yeah, there you go. That's a shader that we created. Perfect. All right, now to go to the fragment shader, I'm just gonna copy this. You might not want to copy this if you're just starting out, because it's easy to make errors, but I'm just gonna change everything here. Fragment core, if the file is open, remember we changed this here as well. We just reset these and we close the file up here, so that's really important to do. Fragment core GLSL, in file is open, we'll get everything into source. I'll just say fragment here for the error. We'll close the file. Let's say fragment shader. We'll change this to fragment frag for the source name, fragment frag. Just make sure everything is kind of changed here. We're gonna have some issues. Fragment shader. So there we go. That should be loaded. Now the program. All right. So just make sure everything is fragment. Just once again, seems fine. All right, everything here is fine. All right. Cool. So the program. Remember, we get a program from the parameter. Well, this is the program we want to change because it's a reference, right, to something outside of the function, because we really want to keep that, the program ID, because it will hold everything else. GL delete shader fragment shader, GL use program 0. This kind of resets what program we're currently using, so the next time we draw we don't have a program already selected. This just resets that, the binding to the program. Anyway, we have this program here, right, that we got from outside of the function, and we want to just say GL create program. So we want to create some space for this program in OpenGL's memory. Now we want to attach some shaders to this program. Remember, we're going to attach them, the vertex and the fragment, and we're going to link them. So GL attach shader to our program, and we're going to say vertex shader, GL attach shader to our program and our fragment shader. So we're basically building Lego blocks, right? We're putting two big blocks together to make one whole, and the whole thing is what we're going to use. So once that's done, we're going to do this GL link program program. Once we've done all this, we'll link it, because in the background this is attached now to some point, and once we link this program, it will use these already attached shaders and try to link it into this program. If we didn't do this before, nothing would happen, it would break. So it's really important. Now again, we need to error check. We can't just leave it here. We need to check if it was successful or not and why it wasn't. So to do that, it's basically the same thing as we did up here. It's just that we do this GL get program IV instead, and we're gonna put in our program, get the thing that we want to check for. What is it we want to check? Well, we want to check the GL link status, because here we're not compiling, we're linking two completed shaders together into a big program, and the parameter is obviously success that we had from before. I apologize if I'm a little slow, but I hope you're understanding what's going on here a little bit at least. So alright, link status success, and then we want to see if it didn't succeed, what happens then? Well, we'll get an error. I'll just copy paste all of this. We'll get instead of get shader info log, get program info log, and program 512 null info log. Error load shaders could not link program, and then the info log. We'll just print that out and boom. And that should be it. That should be our code for loading the shaders. Now if we just try this, just try to run this, I'll want to see what happens. It should work. Something crashed. Load shaders. Oh, excuse me, I'm sorry. Look, I made it a bool, right? So let's just make a bool. Load success equals true. Alright, and we're just gonna go on the bottom and we're gonna return success. Alright, and we're gonna change load success in a few places. Error load shaders cannot open. Vertex file here is one certain area where load success should be false. Load success equals false. I'm just gonna copy this. There we go. Another place is in here. Once success, the compilation is not successful. We're gonna use it here as well again. Sorry I missed this. Takes a little extra time now just because of that. We'll put it here again. Compilation error, and in the link error. Alright, otherwise it will be a success. Now what happens if it's not a success? So what I'm gonna do is, if load shaders did not succeed, I'm gonna say glfw terminate. There we go. Boom. Alright, let me just run this. Alright, we did not get any compilation errors, so these shader files are fine. They're linking fine. Let me just close this. What you want to do is you want to GL delete program at the end of your run as well, because it's really important. glfw delete window, destroy window as well is something you want to do, which I forgot before. Window. I think this takes care of it, but still do that. This is for later, the next one, don't care about that. I'm going to show you the code in just a second. One more thing we want to do, or we'll do that in the next video. You know what, this video is getting long. I just want to show you the code. So basically what happens here is you want to just copy this, just write this in your in your own code. Basically, the vertex shader is the first thing that runs. That's our vertex core. We start off by giving it a version. So version 440. And remember that we made our window, our OpenGL context 4.4 here. See? So we're using the same version in the shader, the GLSL version and the OpenGL version. GLSL is a shader language which you use to create these shaders, and it's kind of C style. So yeah, layout, location 0, blah blah blah. Now this means that it's called input assembly. Basically, in what order this big array of floats is gonna come in with all our points, and what is what. So the first that's gonna come in is the position, and the second vec3, the 3 floats, is gonna be the color, and the third, which is a size 2 vector, is gonna be the vertex text coordinate. Now we'll check all this out and I'll explain it in the next video once we start loading in these points to the graphics card. We haven't done that yet, so it might be a little confusing, but basically this is what you have to do in the vertex shader to tell it what's coming in raw from the CPU, or not CPU, sorry, from the GPU, but what's the first thing that comes in. Now that will be manipulated in here in the main void main. It will be manipulated, stuff will happen here, and then it will be sent out as, if you want to, you don't have to, but it should send out some stuff. Especially the color is important to come, that it comes to the fragment shader. But yeah, we're gonna send out another VS position. Now you can call this whatever you want. You can call this whatever you want as well. But this is important. As long as this is the same as the stuff that comes into the fragment shader, you're fine. So we're gonna send out a vector 3, and a vector 2. The position we're just going to keep exactly the same. Color as well. The text coordinate. The thing with textures is, we'll see later that they're flipped. So what I do is I flip the Y coordinate to actually just flip the picture to the correct, correct rotation. And that's what I do. So see, here is an example of me manipulating the vertex texture coordinates, sending them to the fragment shader as a new coordinate, or new variable. And GL position is OpenGL's final position for this point. So once it's done, we're going to give it the final position of the point, because we're going to change it about a bit in world space and everything, as you'll see, and we'll send it. But here in this case, we're just sending it in just as it was, but it takes a vector 4, so we have to convert it. And how you do that is you make a new vector 4, you put in the 3 x, y, and z from the original position, and then you add a 1 to it. And this 1 is the W coordinate, which we'll talk about later. It's used for perspective. So stuff further away is smaller, yada, yada, yada. We'll talk about that later. It's important that it's 1 anyway. So yeah, that's it. The fragment is going to get in everything we sent out from the vertex. And the only thing OpenGL wants us to do basically is send a vector 4 of a final color for a pixel. So RGBA, red, green, blue, and alpha. This is alpha is the transparency again. So what it wants, our color is going to come in as a vector 3. We just convert that again with a complete opacity, or whatever you call it, no transparency color. And we just send it out, and it will know, boom, this is the final color for the pixel, bam. Whew, that was a mouthful. Sorry about that, guys and girls. But I hope you learned something, and I hope this works for you. It shouldn't crash. You should be fine. Now what will happen if I say, well, I'm sending out something V color, but it's expecting a VS color? What's gonna happen? Well, it's gonna, I think the compilation is gonna crash, and we're gonna get an error here. So what you can do is that we'll just properties, I'll just zoom this in, font size, I'll just say 28. Alright, so error, load shaders cannot compile a vertex shader. Undefined variable VS color 014. It shows you the kind of row where the problem is. Load shaders cannot link program vertex info. Undefined variable VS color, incompatible option for link. This means that we're not linking it properly, though these two are not identical. But as soon as I just add that S again, and we kind of save it and we run it again, you will not have that problem. See? Easy peasy. So there you go, a quick rundown of shaders. I hope that helped. Remember to watch the other video so you know what a shader is, kind of, and read about it. Please check out the graphics pipeline, check out more on shaders, all that stuff. And I hope you learned, and I hope this was okay for you guys. And keep learning. Best of luck, and I'll see you guys in the next one. All right, bye bye.